So how about decimals? And now that we've seen how to eliminate fractions from an equation, can we do the same thing with decimals? Well, decimals don't really bug people as much for some reason as fractions do. So I'll see a lot of students, they'll just leave the decimals in place. Subtract 2 from both sides, divide both sides by 0.1, and you're home free. And there's absolutely nothing wrong with that. Okay, you'll absolutely get the right answer that way. But we can eliminate the decimals in the same way that we eliminated fractions, and sometimes it is useful to do that. So here's the technique. Right, I'm seeing I've got a 0.1 and a 0.9. So I am going to multiply both sides of this equation by 10. Right, why 10? Well, just bear with me, right, and see what happens here. This is going to be 10 times 0.1x plus 10 times 2, that's 20, equals 0.9 times 10, that's 9. I see how the decimal went away over there, which was my goal. Now over here, I've got 10 times 0.1, which is 1. So this is just 1x, or x, plus 20 equals 9. Subtract 20 from both sides, and we're done. X equals negative 11. Again, you can go back and check that, right, if you have the time or you feel you need to. All right, so how about this one? Here, this is, again, I said there were going to be a subtlety here, okay, and this is where you're seeing it with this equation. If I multiply both sides of this equation by 10, I'm not going to get the desired result. Right, the right-hand side becomes 10 times 0.5, which is 5, so that's 5x, minus 30. Now look at what happens over here. 10 times 0.13 is 1.3 times x minus 1. And the decimal's still there. Multiplying by 10 wasn't good enough. Right, but remember, just like when we talk about fractions, when you eliminated one fraction, like we eliminated the one decimal on the right-hand side, and we still had a second one, that was okay. Just do it again. So let's multiply both sides by 10 again. 10 times 1.3, that's 13 times x minus 1 equals, let's distribute that 10, 50x minus 300. Now the decimals have all gone away, right, which is what we needed to happen. All right, so let's finish solving this here real quick. This is 13x minus 13 equals 50x minus 300. Add 13 to both sides. 13x equals 50x, 300 minus 13, negative 287. Subtract 50x from both sides. 13 minus 50, that is minus 37x equals negative 287. Okay, divide both sides by negative 37. X equals, the negatives cancel, right? So this is 287 37ths, and that's a bizarre fraction, but, you know, the answers come out to what they come out to, especially when you're doing real-world practical kind of problems. The real world doesn't have the love of integers that a lot of math students do, so you can't count on the answers always coming out to something nice and even. Now, this is a situation, and we talked about converting to decimals before, right? This is a situation where I would say it's okay to convert this to a decimal, right? Because the original question used decimals. So I always tell my students, your answer should be in the same format as the original question. So if you go to your calculator and ask it what this is, your calculator will tell you that it's, in fact, a repeating decimal. So this is, I would say, approximately equal to 7.756, and it goes on and on and on. So next question you've got to deal with, right, is where do you stop? How many decimal places should you give your answer to? Well, when I'm doing this with my students, I don't get super picky about it. The science and engineering guys, they have all sorts of rules for this kind of thing. I don't worry about it that much. If you're looking for a rule, I would say the biggest decimal up here has 2 digits. This one has 2. This one only has 1. So I would round my answer to 2 digits, 2 decimal digits. So I would go with 7.76. But this is a situation where you really need to talk to your teacher, your professor, see what their specific expectations are. Okay, now, before we move on, let's take one step back. Remember how we said in a situation where we multiplied by 2 different numbers to eliminate fractions? I said, well, you could have done this in one pass if you had just multiplied by those 2 numbers multiplied together. Well, we can do the same thing here. What did I do with this equation? Well, I multiplied by 10, and then I multiplied by 10. Well, multiplying by 10, then multiplying by 10 is the same as multiplying by 100. So I could have just done that right here from the beginning, multiply both sides of the equation by 100, and I would have eliminated the decimals completely on a single step. And if you're looking for a rule, right, what number should you multiply by? Well, again, look at the number of decimals. There's 1 decimal number here, 2 decimal digits here. Okay, well, if there's 2 decimal digits, if that's the biggest number, then you multiply by 1 followed by 2 zeros. So again, just another quick example, if I have 0.137 times x minus 1, right, this has 3 decimal digits. So in this case, I would multiply both sides by 1,000. Just like we saw with the fractions, that way you could eliminate the decimals with one calculation. All right, so that's our introduction to working with solving linear equations in one variable. In the next couple of lectures, we're going to kind of do to mathematicians. We can never leave well enough alone. So we're going to say, well, okay, if we can do this with equations, can we do it with inequalities? So that's what we're going to look at in the next couple of lectures. Turns out the rules for doing the inequalities are very similar to the rules that we've already learned here for solving equations.